So we've studied in Chapter 4 all things related to quadratic formulas, quadratic equations, quadratic functions. We've learned many different ways to solve all of these quadratics. Ultimately, let's deal with the quadratic system as well. A system of equations is simply two or more equations put together that share variables, and we want to identify where those equations touch. I have three different examples of a quadratic parabola created. If I had a linear line pop through here, you could see that I would have, just as a reminder, I would have two solutions. If I had something linear come through this way, it might only have one solution. Or you could have something linear come through and have no solutions. And just like linear things could touch it at 2, 1, or no places, you could have another quadratic in there, of course, that could touch at 2, 1, or no places also. So quadratic systems exist, and finding out where they touch is going to be done, well, pretty similarly to how we've done every other system we've worked on. You're going to use graphing, or you're going to use substitution. I'm not going to choose to use elimination on this, and I'm going to demonstrate both of them. So I have a sample system. Instead of spending time in this video showing you how to graph one more time, I'm going to go ahead and cheat it a little bit, and I'm going to use Desmos to graph this because it's just so darn easy. So solve the system above, right? If I want to solve this guy, I've already typed these two equations into Desmos, and you're going to find that here they are. The top one in blue, the bottom one in green. I can tap the screen and find out that one of my solutions is 0, 6, and the other solution is at 4, 10. Those are my two solutions. It's that easy. All right, 0, 6, 4, 10, and I'm done. Now it feels a little bit like cheating to use Desmos on this, but graphing is graphing. So whether we do it by hand or whether we do it using some tools, that is ultimately the solution. Now with that in mind, let's go ahead and get back to notability. Let's get rid of this, and let's solve it a different way. So we've solved it with graphing. We know what the solution is. Let's also solve it with substitution, because maybe there's a time when graphing isn't convenient or you don't have access to that tool. What I observe here is that I could pretty easily put this x plus 6, which equals y, into the other equation in the y place, and I would get x plus 6 is negative x squared plus 5x plus 6. And this is a little bit messy, so what I'm going to do is what I've done in every other problem. I'm going to move everything to one side. I see that there's a negative in front of the x squared. I'm not really scared of that yet, but I am going to move these two things using the same operations to both sides over. And now I find myself with all kinds of options. I can solve this with, gosh, I could graph this if I wanted to. I could solve this with factoring, which is what I'm going to do. I could solve it with completing the square if I made that negative sign, if I factor out that negative 1. I could use the quadratic equation. Lots of options. For sake of argument here, I'm going to go ahead and factor out a negative 1, x squared minus 4x. Now I'm going to factor out a common x, and I'm going to have x minus 4. And now I'm going to go ahead and use the zero product property. Zero product property means one of these two things must be equal to 0 if their product equals 0. So either negative x is 0 or x minus 4 equals 0, or both. And if negative x equals 0, divide by negative 1, I get x is 0. If x plus minus 4 equals 0, I get x equals 4, and you're going to notice that those line up with my x values from graphing. And I'm going to save you the time right now, but you could imagine that I could put those 0 values and the 4 values back into either one of the two equations. I'd probably pick the bottom one because it's going to be a whole lot easier. I could figure out my y value is 6, so 0, 6 using substitution, or put the 4 value in there. 4 plus 6 is 10, so 4, 10. So using something like Desmos is a great way to solve a system of quadratics. You could graph it by hand, but I don't think I would do that, to be honest. I'd probably, if I were going to do something by hand, I would go ahead and solve it using substitution. So good luck with all things related to quadratics, including quadratic systems of equations.